Is my screen visible?
Yes, Varun.
Okay, so uh, so as mentioned earlier, what we'll do today is try to understand what MuleSoft Transit Gateway is, what kind of problems it helps us to solve, and the product in general of how we can make use of it for different use cases, as well as the benefits. And we'll try to compare it with all the other different connectivity options that MuleSoft AnyPoint platform provides us. Okay. Okay, so before proceeding further, there's a few things that we need to refresh about, especially about VPC and the connectivity options, because these are the core concepts or the core principles when it comes to transit gateway. So we'll do a quick refresh of VPC and the current connectivity options that MuleSoft provides us. Okay. So to start with, what is a VPC or a virtual private cloud? I think most of you might have worked either directly or indirectly on a VPC, maybe in some of your client engagements. But just to refresh for the wider audience, what a VPC is or a virtual private cloud is, it's like an offering provided by AWS, which MuleSoft makes use of. Okay. And what it does is it allows the creation of virtual, private, and isolated networks in the cloud to host our own cloud of workers. So, for example, AWS is a large cloud, right? So, it's a multi-tenanted cloud. All the clients can have their applications, all their workers over there. But let's say if a particular client wants all their workers or all their applications in a private space, in a private isolated space in that entire AWS cloud, then that's where VPC comes into picture. Okay. That's the main benefit or the main purpose of having a VPC. The other specifics are that a VPC is region specific. So when we say region, it's an AWS region. So AWS provides multiple regions all across the world. For example, US East 1, US East 2, US Asia Pacific, and all those things. So what we say is when VPC is region specific, it means that one VPC can belong to only one region. It is not a global service, so it cannot belong, one VPC cannot belong to all the regions. It has to be tagged to either one of the region that AWS provides. Okay. The next and the most important thing is that since it's a private cloud, we can configure access inside and outside of the cloud. So what VPC provides us is some kind of a firewall rules by which we can control uh, any outside request that they want to access the applications inside the VPC. And then when it comes for networking purpose, what we have is that we can pair up our MuleSoft VPC with other AWS VPCs or other on-premise networks. So on-premise networks is basically, let's say, a client-side network which is there. It might have a relational database. It might have a mainframe system over there, which is completely on-premise. And let's say if you want to connect those things to Cloud Hub, to any one platform, then the best way to do it is to connect on-premise network with the VPC. Okay, so since everyone now knows about VPC, let's see all the different options by which we can connect a a MuleSoft AnyPoint VPC with either our corporate data center or other VPCs. So the first option is AnyPoint VPN, which is a virtual private network. What it helps us to do is, if you see this diagram, it helps to connect our MuleSoft Cloud Hub environment with the VPC in it to a corporate data center. Okay. So what happens is that we create a VPN tunnel, and through that tunnel, the VPC gets connected to the corporate data center. Now this tunnel is completely secure. It uses IPsec, okay, for the encryption. It is highly available because normally when we create a VPN, it creates two tunnels. So let's say if one of the tunnel is down for maintenance or for some other purpose, then the other tunnel is always up, and we can make use of that. Theoretically speaking, it has a throughput of 1.25 Gbps, so the data transfer in it is limited to 1.25 Gbps. And one of the most important points is that it is completely self-serve. So we don't need to raise a MuleSoft support case or support ticket to set up an AnyPoint VPN. There'll be a few tasks that you need to do at the AnyPoint platform side to set up the VPN, and the rest of the tasks you need to do at the AWS side to complete the connection. Sorry, not the AWS side, the data center side, the corporate data center side. So this is connectivity option number one for connecting VPC to the outside world. Let's go to the next option, which is AWS Direct Connect. So the one above is the VPN part. The one below is AWS Direct Connect. AWS Direct Connect is somewhat similar to VPN, but it is a completely different offering. So what happens in AWS Direct Connect is that if you have a data center, let's take an example that you have a corporate data center in Mumbai. If you need to connect it to Direct Connect with Cloud of VPC, then what happens is that that data center gets connected to your nearest AWS Direct Connect location through lease lines or fiber optic cables. So there are actual physical cables that are laid from your data center to your nearest AWS Direct Connect centers. Now, AWS has Direct Connect centers worldwide in almost multiple places. So let's say if we have a data center in London, then there'll be obviously some kind of a data center Direct Connect center in somewhere in the UK. So what will happen is that there'll be a physical cable laid out from the data center, the AWS Direct Connect data center, to your corporate data center, which is a dedicated cable for you. And then what happens is that those direct connect data centers get routed across the different direct connect data centers across the world, which in turn then will finally connect to your MuleSoft Cloud of VPC. So if you see this entire network traffic that will go through, firstly it will be through the cables, the physical cables, and then the rest of the traffic will flow onto the AWS network itself. So it will never go onto the public internet. It will be all dedicated and inside the AWS network itself or your private lines that connect your direct connect center with the corporate data center. Okay. So as per the AWS specification, it can guarantee speeds up to 10 Mbps. The other benefit of direct connect is that we get a consistent network performance, mainly because we do not use the public internet over here. It's all dedicated infrastructure in place. And again, over here, the difference with VPN is that you need to raise a support case. So this part of the connection, laying out the physical cables as well as getting all the infrastructure ready for direct connect, we cannot do ourselves. We'll have to raise a Mulesoft support case, and they help us in getting all this set up done. Moving on to the third one, which is, I think, the most commonly used, or I would say maybe not the most commonly used, but the most simplest form of connectivity is the VPC peering. So in this diagram over here, you can see the first section over here, which is the VPN, the one below the direct connect. And the third one over here is the VPC peering. VPC peering is straightforward actually. What it does is it connects your VPC, which is in your AnyPoint platform account, with another VPC, which is any other VPC in AWS. Okay. So the restriction is that it can only connect to other VPCs in AWS. Okay, so it cannot connect to completely different clouds and corporate data centers or something like that. It has to connect to a VPC itself in AWS. Now the VPC might belong to your account or some other account. That is fine. We can manage that connection, and that connection from AnyPoint VPC to your AWS VPC is something which is called as VPC peering. Okay. The thing with VPC peering is that, again, we'll have to raise a support case to get this setup done. So MuleSoft has to be involved to get the VPC peering done from your AnyPoint VPC with your AWS VPC. And more importantly, VPC peering does not support transitive peering relationships. So when I say transitive, what I mean is that, let's say you have this one VPC and you're pairing it with this another VPC. Now, maybe your AWS VPC already has a VPC pairing with a third VPC. Okay. But that does not mean that your AnyPoint VPC can directly access the third VPC just because that is connected to both the networks. So that is a transitive relationship in place. VPC peering is not transitive. So you need to have a separate peering relationship to the third VPC if you need to connect both the VPCs together. Okay, so that actually brings us to the newest or the latest offering from MuleSoft, or I would say from AWS, called as Transit Gateway. So Transit Gateway was a feature, or I would say a product launched by AWS somewhere around late 2018. And then MuleSoft actually started using Transit Gateway, I think last year, somewhere around mid of last year, I guess. And the main purpose of using a transit gateway is to simplify the overall network. Okay. What transit gateway does is it can connect to any different AWS VPC or to even any on-premise networks. So when I say on-premise networks, it's all the customer networks that we just discussed before. It acts as a single router. So if you see something in this picture over here, it acts as a single router, a gateway or a router. In fact, you can call it as a cloud router. And then all your devices or all your networks can basically connect to that router. And what then happens is that it routes the traffic from one destination to the other destination. So let's say if this VPC needs to communicate with the other VPC, it can send a traffic to the transit gateway. The transit gateway can then forward it based on the IP address to the next VPC. So if the IP address is for, let's say, this VPC, it will automatically transfer the traffic to the other VPC. Now, how it does this is basically because it operates on layer 3 of the OSI model. So if you know layer 3 of the OSI model, it's the network layer in which packets get forwarded on the IP address. So that's what the transit gateway is based on. It works on the IP addresses. It does work on IP4 as well as IP6. Okay. Uh, and what we'll realize in the later slides as well as in this demo is that it will put an end to all the complex networking relationships, especially the peering relationships. So if you see over here, all the devices or all the networks connect directly to the transit gateway. They don't need to connect to each other. So that's a single biggest advantage of using a transit gateway. Any new device or any new network, any new VPC, it has to just directly connect to the transit gateway. And then it is connected to all the other devices, all the networks that are already connected to it. Now, traditionally, a transit gateway is just like a VPC in the sense that it also is associated with one region. So when we create a transit gateway, it is associated with one region in the AWS infrastructure. Right? So it can be US East 1, US East 2, or some other region. It is tagged to one region. But the beauty of transit gateway is that you can peer a given transit gateway with another transit gateway, which can be in another region. So you can have this transit gateway in US East 1, Ohio. Oh, sorry, US East 1, I think is Virginia or something. I don't know, but US East 1 we can have as one transit gateway, and then the other one you can be in US East 2, or you can have it in US South or UN West, or even any other region across the world. So we can pair two transit gateways. So what that does is that it increases the scope of the network without doing much complex connections. Just that one peering connection is needed from a transit gateway in one region to the transit region in the other region. And then you'll be connected to all the other VPCs and all the other on-premise networks that the second transit gateway is connected to. Okay, so that is something called as inter-region peering. So just like we saw VPC peering earlier, this is like transit gateway peering, or also called as inter-region peering. The other benefit is that since this is an AWS offering, it is completely managed by AWS and it is highly scalable and available. We don't need to worry about the availability of it, downtimes, and all those things. It is all managed by AWS itself. Okay. And another most important point is that it is just like I think it was VPN, right? Yeah, just like VPN, this is also completely self-service. We don't need to need a support case. We can get it set up and working ourselves. The only thing is that we'll have to do some part of the configuration at the AnyPoint platform side and some part of it at the AWS side. Okay. Okay. So before we proceed further, I think everyone needs to understand a few key concepts and terms when it comes to transit gateway. So normally when we talk about transit gateway, we talk about transit gateway attachments or just attachments in general. So what we mean by an attachment is any offering or any product offering from either AWS or anything outside such as an on-premise network, which can be connected to a transit gateway. So what all can be connected to a transit gateway? And the answer is we can connect one or more VPCs. So if you see, we have this VPC, the other VPC, in fact, 4 VPCs which are connected to this transit gateway. We can also connect a AWS Direct Connect to this gateway. So we can have a Direct Connect gateway connected to the transit gateway. We can have a transit gateway paired with another transit gateway, as we discussed in the previous slide. And the last option is we can have a VPN connection. So if you see this part, we have a VPN connection that connects to a customer gateway. So just by looking at this diagram and all the attachments possible, I think it will be pretty clear that we can connect everything via just one device or via just one product offering that we can connect via multiple options right now. So right now we used to have something different, a VPN connection for VPN, VPC peering for Amazon VPC, and Direct Connect for a completely different use case. But by using AWS Transit Gateway, we can club all of them. We can make sure that everything connects to the Transit Gateway. And then the benefit, as you'll realize later, is that we'll just need one connection from MuleSoft Cloud Hub to the Transit Gateway, not multiple connections. Okay. Now the other term when it comes to transit gateway is the routing that takes place across the different attachments to the transit gateway. Okay, so normally what we do is we have two kind of attachments. We either go for VPC attachments or a VPN attachments. I've not considered the direct connect attachments over here or the inter-region transit gateway attachments. Let's focus on just these two attachments, the VPC and the VPN attachments. So when it comes to VPC attachments, the routes are propagated. I mean, they're actually static routes which are getting propagated across to the transit gateway. This is a core key concept that we need to understand, that when it comes to VPC attachments, the routes are basically static routes which are getting propagated from the VPC to the transit gateway route table. And for VPN, there is kind of a mandate from AWS side that it has to use dynamic routing or the BGP. Okay. So for the rest of this session, as well as for the demo, we just want to focus on the VPC part and the static routes part. We will not look into this part. Main reason being is because when MuleSoft basically connects to Transit Gateway, it connects as a VPC attachment, not as a VPN attachment. Now, let's try to quickly understand how this routing takes place. So if you see this diagram over here, we have 3 VPCs, VPC 1, 2, and 3. With VPCs, I think most of us already know that VPCs are associated with a CIDR block. So VPC 1 has a CIDR block. Let's assume it has 10.0.0/16. Similarly, VPC 2 has 10.1.0.0/16, and the third one has 10.2.0.0/16. Okay. So if you see this, now 3 VPCs are connected to this transit gateway via VPC attachment. Okay, so all 3 of them are connected to this transit gateway via the VPC attachment. How does the route table inside this transit gateway get changed when the attachments are indeed attached to it, this device? So if you see this table over here, it shows how the transit gateway route table will look like. So there'll be something called as a destination, and there'll be something called as a target. Okay. What happens is whenever any request receives or reaches the AWS Transit Gateway, it will check the destination IP address, and based on the destination IP address, it will select a target VPC or a target any, whether it is a VPC or any VPN from the target section over here. Okay, so let's take an example. If VPC 1 has to send traffic to VPC 2, okay, so it will send something on one of this IP address from this CIDR block. So let's say if it sends some request on 10.1.0.1, that request reaches the transit gateway. The transit gateway sees that the destination falls into this second row, which is for VPC 2. So what it does is it routes the traffic or that particular request to VPC 2. Same way, if VPC 2 wants to send something to VPC 3, it will send a request which reaches the transit gateway. The transit gateway will understand that the destination IP address falls into this. It actually matches this record entry in the route table. So what it does is it will forward that particular request to VPC 3. Okay. So this is in a nutshell how the routing works in a VPC, sorry, in a VPC attachment when it is connected to a transit gateway. Now let's try to understand all the benefits that we can see for using a transit gateway as compared to the other connectivity approaches. So what we have over here is a simple network diagram, okay, of how the network will look like when we don't use a transit gateway. So the use case over here is that we have to connect three VPCs to each other and one on-premise network. Okay, so three VPCs, this VPC, this, and this, we have to connect to each other. And also we need it to be connected to a client network or on-premise network. So for connecting to on-premise or a client network, we need this customer gateway, which will be at the client side. And then we need to VPN connectivity with this VPC, with this VPC, and this VPC. Okay, so that will ensure that there is a connectivity to the client network across all the three VPCs. But still the three VPCs are still not connected to each other. So connecting this VPC to this VPC, we need a VPC peering in place. For this VPC to this VPC, we need another VPC peering. And for VPC, the first one to the third one, we need to have another VPC peering in place. So what you can see is we have three VPN connections and three VPC peering connections in place, a total of 6 separate connections. This looks quite okay. It's not that overly complex, but let's try to understand what will happen when we try to put a fourth VPC. Okay, so when we try to put a fourth VPC, what we will need to do is that we'll need to add 3 additional VPC peering connection, because the new VPC has to connect to this VPC via VPC peering. It has to connect to this VPC via VPC peering, as well as to this VPC via VPC peering. So that is 3 additional VPC peering connections, as well as it needs a connection via VPN to the customer gateway. Okay, so this is what we see: 3 additional VPC connections and 1 additional VPN connection. So overall, when we just add one more device to the network or one more VPC to the network, the count of the network connections increases to 10. Now I would leave it to you just to calculate when we add another one, that is the fifth device or a fifth VPC, how much connection it will take. And you can update the diagram accordingly. But I think what everyone has understood is how complex the network will become as and when we keep on adding VPCs or other client networks. Now let's try to compare this with how the same network configuration will look like when we're using a transit gateway. Okay, so still again it is 3 VPCs itself, and there is one customer gateway for the on-premise network. So this connects via VPN attachment to the transit gateway. This VPC connects via VPC attachment to the transit gateway. So with the other two VPCs, they connect to the transit gateway via VPC attachments. So what we have in this is one VPN connection and 3 VPC connections or attachments. So overall, it's still 4 over here for the basic use case. But then, let's say if we add the fourth VPC to the network, what will happen is that we'll just add a new VPC. Via VPC attachment, it will just connect to the transit gateway. That's it. Nothing else has to be done. Just one new connection. Okay. So only one additional VPC attachment will be needed. So the total number of connections that you'll have to manage or your network administrator has to manage is only 5 as compared to 10 in the previous case. And as you might have realized, if you keep on adding the 6th, 7th, 8th VPC or the customer network, we'll see a drastic improvement, or I would say a drastic simplicity or cleanliness in the entire network. Okay, so now let's come to the point where we discuss how MuleSoft actually connects with the AWS Transit Gateway and what is the connectivity looking like. Okay, so consider this as the AWS entire region, the AWS entire cloud, and this is one region, the
Hey, Bhoapl.
EC. Okay, yeah,
So can we take question?
yeah,
Few
yeah, sure.
questions.
Yeah, please, yeah.
Yeah. So basically, the first question from Shubham. Question is, side to side doesn't provide transitive capability, right?
You mean to say? Do you mean to say when, let's say, from one VPC we are connecting to one on-premise network, and then that on-premise network is connected to the other on-premise network? Is that what you're saying?
Let me check with Shivam.
Yeah, I replied yes.
Yes.
Okay. To be honest, I've not tried it. I'm not sure if anyone has tried it or not.
Okay. Yeah. So another question.
Mhm.
It seems like CDM for formats. We we have transitive gateway for networks.
I didn't
This
get the
is
question.
so basically, let me read out again. It seems like CDM for formats. We have transit gateway. Let me unmute
Okay,
Amit.
okay.
Go
So I
ahead.
think it is for formats, we have a uniform canonical data model. Is that what you're saying? Just like that, for all connectivity, we are having transit gateway. Something like that?
So let me, Amit, I have unmute yourself. Amit, I have provided access. Can you unmute yourself? So meanwhile, Amit is.
He had replied yes on chat.
Right.
Oh,
Okay. I think
sorry,
I
sorry,
understood the
sorry.
question.
I was talking in mute. So I was saying
Okay.
that for it is like similar to we have a canonical data model for different formats. As, for example,
Right.
we have 10 targets. So instead of converting a particular format to 10 different specific target specific formats, we are converting into a common CDM format. Then we are going for that, so that in case the 11th target comes, we are not doing anything. Seems very similar to that.
I would say, yeah, kind of, because instead of using 10 different connections, you're just using one connection. So if we just compare that part, then yes, it is same. Uh,
Yes.
the difference is that you don't have to convert anything over here. Okay, for
Yes.
example, in CDM, you'll have to convert to CDM and from CDM, right? So
Yeah.
all those things will not be over here. You have to just send the traffic to transit gateway, and then it will forward it accordingly.
Yeah. Correct.
Yeah. Thank you, Amit. Thank you, Vaibhav. So another question from Pavan. What is the cost associated with it? Transient gateway.
Okay, so the cost, there's a complete different section to the pricing. So should I discuss it now or maybe later? In
Maybe,
fact,
yeah.
what we can do is there's a, if I can just quickly maybe show. So if you go to this link, transit gateway pricing, the cost is not something straightforward. So there are two things. Okay, one is the cost when we say from the MuleSoft side, or in general the AWS transit gateway costing and all those things. So if you see the AWS transit gateway, there are hourly charges, okay, which are defined over here, as well as there are data processing charges, which are mentioned over here. Okay, there's a pricing calculator and all those things, so you can put how much your requirement is, how much data you're going to send, how much attachments are going to have. So all based on all those things, you'll be charged. So should I ping this link on the channel? Is that going to be easier?
Yes, we have a link in the chat. Thank you, Subham.
Yeah. So
Yes, you
all
can also.
pricing related things will be there at that AWS link.
Yes. Okay. So another question from Pavan.
Yeah.
In which situation do we need more than one VPC for an enterprise? Generally, we use one for prod, another one for non-prod, isn't it?
Right. Okay, so let's say if you have, let's say if you have corporate networks, okay, or for example, I would say, let's say if you have to connect to, your client has AWS infrastructure and they have their own VPCs, which are in multiple regions. Okay, so let's say one is in US East 1, and the other VPC that they have is in US East 2. Okay, so in that case, okay, if your MuleSoft VPC, as you know, MuleSoft VPC can reside only to one region. Okay, if you have to connect to that particular Amazon VPC, AWS VPC, then you can only connect, let's say, via VPC peering to that particular AWS VPC itself, because it needs to be both in the same region. So this might be one case in which if your destination VPCs are in different regions, you might need different VPCs at all in the MuleSoft side. But traditionally, we have not seen anything like that. And to avoid those kind of complexities, normally we can go with the products such as Transit Gateway, so that the VPCs can attach to the Transit Gateway, and then Transit Gateway can then directly pass on the traffic to the appropriate VPC. Does that clear up the things or your question?
I think
Yes,
yes.
Vaibhav. Yeah.
Thank you, Pawan. So let me move to. So basically, from Amit, I think it is a kind of confirmation that so we are moving from mesh structure to ring structure or ring plus bus structure if we are going to use
I
transient gateway.
I think it's called as a hub and spoke structure, right? Something like a I think it's called as a hub and spoke structure. It's like there's a central hub, and everything connects to that hub, and then that hub that then forwards all the traffic to the different spokes or the connections to it. So I wouldn't call it as a ring structure. I would call it as a hub and spoke structure.
Yeah. Thank you. Question from Darshan. Suppose I need to add a VPC number 4, but don't want to have connectivity with VPC 3.
Okay.
But
Okay. So
but
what you're saying is that you need to add one more VPC over here. You need it to connect to everything else, but you don't want it to connect to just this one VPC, right? So yes,
correct.
that can be done. What will happen is that at the VPC level itself, you can block the traffic such that the traffic from your VPC will not go to that particular VPC, as well as traffic from that particular VPC cannot go to this. So either you can do it at the VPC level or at the direct connect, sorry, at the transit gateway route table level itself. So we can control those things.
And using transient gateway, means,
Yeah, so using transit gateway, there's a route table at the transit gateway level. So what we can do is we can ensure that that route table is updated such that the traffic does not flow from those two VPCs to each other.
okay, yeah. Thank you. Another question from Rohit isn't transient gateway single point of failures? How it is highly available?
That is something that is handled by AWS itself. So, I mean, how they have implemented it is, I think it will be a completely different topic, how they've implemented high availability and all those things. But that is what the documentation from AWS is, that it is completely highly available and we don't need to worry about it. It will be always available.
Yeah. Okay, so I think we have completed all questions.
Great. Okay. Can we move ahead now?
Yes, yes.
Perfect. So what I was trying to explain over here in this diagram is how MuleSoft connects to the transit gateway. So the actual transit gateway does not get created in AnyPoint platform. That is the first thing that we need to understand. The actual transit gateway resides in the AWS side. Okay, the AWS side of the client's infra or our infrastructure. What we do when we create a transit gateway in AnyPoint platform is basically we connect our VPC to the transit gateway via the VPC attachment. So if you remember, there's different kind of attachments, VPC attachments, VPN attachment. So what we're doing is, since we are connecting our AnyPoint VPC with the transit gateway, we are going via the VPC attachment route. And what happens is this VPC gets attached to the transit gateway. Okay. Once this link is set up, this link, let's say if it is already there, okay. So for example, VPC1 has route to transit gateway, VPC2 has route to transit gateway. VPC1 has some EC2 instances, it has a database or any other thing. Similarly with VPC2, once we establish the link from our VPC, the AnyPoint VPC to the transit gateway, automatically the traffic can flow from here to VPC1 or from our VPC to VPC2 and vice versa. That is from VPC1 to AnyPoint platform as well as from VPC2 to AnyPoint platform. Okay. Now, the topic that we briefly touched earlier, which is the inter-region peering. So how this works, so this part of the diagram remains the same. It is exactly the same. Okay. The thing to note over here is that a VPC, that is AnyPoint Platform VPC, is in US East 2 region. I will just put a separate color for that region just to match it with this region. So this particular VPC at the AWS side is also in the same region. So what we're saying is that the region is mapping, it's matching for the AnyPoint VPC and one of the regions where we have some of our EC2 instances and databases. So if that is the case, we'll just have a VPC attachment connected to the transit gateway in this region and everything will be fine. But if the client has another region in which they have some additional resources, so this is, I think, one of the questions that we had, right? So this is another region over here, US West 2, also US West 1, okay, and the client has certain EC2 instances over there. They might have databases or something else over there. How do we connect these resources via this transit gateway? So the thing is that we cannot connect this transit gateway in US East 2 directly to this resources or to this VPCs, I would say. What we need to do is we need to have a different transit gateway in US West 1 region, and then we need to peer this transit gateway with this transit gateway. Okay, so this is the AWS transit gateway peering concept. So it will be a peering attachment over here. So just like this is a VPC attachment, this is going to be a peering attachment between the two transit gateways. So once this is done, then basically any application, a Mule application or a Mule API in a VPC, in the MuleSoft VPC, can access EC2 instances or databases in VPC 1, 2, or VPC 3 and VPC 4. Okay. So this is one of the challenge right now that we cannot do, or it is very difficult to do it. But now with VPCs, with transit gateway, and especially with transit gateway peering, it is made quite easy. Okay.
And basically, I have one question from my side.
Yeah, sure.
So Mulesoft VPC and AWS VPC having a VPC attachment, but we are connecting two transient gateway. So between them, we are also connecting any attachment or any link.
Yeah.
What will?
So this is a MuleSoft VPC on the left-hand side that is getting connected to the transit gateway in US East 2 via VPC attachment. And why is it as a VPC attachment? Because we are attaching a VPC to a transit gateway. Hence, this is a VPC attachment. But when we are connecting two VPCs, so let's say, not VPCs, a transit gateway. So this is one transit gateway. This is another transit gateway. We have to connect this transit gateway to this transit gateway. So at that time, it makes no sense to have a VPC attachment, right? Because we're not connecting a VPC to the transit gateway. We are connecting a transit gateway to another transit gateway. So this attachment is called as a peering attachment or a transit gateway peering attachment. I forgot to mention it over here, but this is a peering attachment.
Okay. Yes. Okay. Thank you, Wevo. So there are basically two questions. Does CloudHub support integration with similar offering from Azure?
As of now, what I know, then the answer is no. This is only for AWS.
Okay.
So what you can do is, there's a solution for it, right? So if you have something at the AWS side, if the client has something at the AWS side, they can have a transit gateway. Just one transit gateway. They can connect all their VPCs, which are AWS VPCs, and then for anything outside the VPC or the region, or even in fact AWS, such as an on-premise network or any Azure network or GCP, they can go via the other routes, such as the VPN routes or the direct connect route. So even the VPNs, they can connect to the transit gateway. Even the direct connects, not the direct connects, I think just the VPN routes. So via VPN route, they can connect to the Azure networks or the GCP networks or any other cloud networks. And the data from them also will flow to the transit gateway across to the VPCs as well as to your MuleSoft VPC. So that is the thing that we can do. But out of the box, just like the facility it provides for transit gateway, I'm sure there are other products also from GCP as well as Azure, but we do not have support for those products as of now.
Okay. So another question from Gaza.
Yeah.
Only problem we have here is BPC and TG should be in same region. Could you please enable my mic? Okay, so basically, I think let me enable. I just enable a mic for Gaza. I think you have to unmute yourself.
Thank you. As you said, this transit gateway is simplified and networking. So the only challenge here is, let's suppose a scenario, we have a cloud hub in East 2 region, and data center is in East 1. We have a hybrid. Suppose we have a hybrid deployment option, right? So now, if the third data center, if you want to connect, that is in a different region. But the transit gateway here we have we have to have in the same region with the cloud hub, right?
Yes. So the initial pairing that you do with the transit gateway, right?
Yeah,
Okay. That has to be in the same region.
yeah. If it is
Okay.
not, then
Yeah. So let's say you have some devices, as I mentioned, in this particular region, and you have some devices which are not in this region. You have in a different region, just like this diagram.
mhm.
Okay, so this is, I think, exactly the diagram or the solution that you're looking for. That you have certain, let's say, EC2 instances databases in one region, and certain other, maybe you or your client has certain instances, databases, or some other things that you have on some other region, whether it is US West one or any other region, that is irrelevant. It is different to the region in which the transit gateway is there. So in that case, the best solution offered by AWS is that have a transit gateway over here as well as in the other region. Okay. Connect your transit gateway, which is in the same region as your cloud of VPC via the VPC attachment, and then pair this transit gateway with the other region's transit gateway via peering attachments. So once this is done, you have this entire three VPCs, that is this VPC, US East 2 over here, as well as US West 1 over here, all three connected to each other, and they can send traffic to each other.
Okay, this transit gateway solution only work for cloud hub?
I mean, what exactly
Means
do you
like
mean
our
by?
VPC, AWS VPC should be like, let's suppose I have a data center that is already in AWS, right?
Okay.
And so every all the applications are deployed on the data center, AWS data center,
Mhm.
right? Now that data center is in East 2. Okay.
Okay.
So will this AWS provide a transit gateway also there?
So you mean your data center is in US East 2, right?
Right,
This region. Okay.
right.
So it will be like, I mean, if you consider it, it's just like an EC2 instance or a database. You have a data center over here, right?
Hmm.
So which is in AWS.
Right.
So you can connect whatever is there in that region, you can connect via transit gateway.
Uh, I'm just asking about the transit configuration, how the AWS provide that. Like, let's suppose our data center is in East 2. So will they
Hmm.
provide this facility in East 2 only?
So your question is, will they provide transit gateway in East 2?
Right.
Yeah, so the thing is, transit gateway, as we'll see in the demo, we can create in any of the regions. I mean, that AWS provides, or
Yeah.
I think there is a list of regions at least that
Hmm.
we can do. The only caution I would say is, let's say when you're doing it with Cloud Hub, because as far as I know, or I may be wrong over here, when we select a VPC in Cloud Hub, it allows us to select only specific regions in the drop down. It does not show all the lists. I'm not sure if there's any kind of decision based on which it populates a drop down, but it does not show all the regions over there. So as long as that region is there, then you can just connect it to the AWS region over here. That is the only constraint I can think of. Otherwise, you can have this transit gateway in any of the regions where AWS is providing it.
So AWS is flexible enough; they can provide a configuration in their region, right?
Sorry, your voice is breaking a bit.
I'm saying AWS is flexible enough; they can provide a easy configurations in the region that we are residing or our application is.
Yeah.
Okay.
So either
So
AWS will have that for that region or it will not have it. So if you see the region specifications or maybe if you see the transit gateway specifications,
mm,
I'm sure it is available in most major regions across the world. Maybe some of the new regions they might not have it, but obviously in the future they might put it over there. So the AWS spec or the AWS documentation, you'll be able to know whether transit gateway is supported for that particular AWS region or not.
okay. Yeah, thank you. So I just checking the boundary of the transit with respect to the region.
Yeah, only thing you need to check is for the region that you want, if transit gateway is supported or not by AWS. That's the only thing you need to check.
Mm.
In
Yeah.
fact, if you log into your AWS account and switch to the region, if you are able to create a transit gateway over there, then you are able to basically do it. I mean, have the transit gateway over there. Okay.
Thanks, Abhishek. All direct. Appreciate your work.
Thank you, Gaza.
One question, Vaibhav here. So, do we need to raise a MuleSoft ticket for?
No, no,
Uh,
no. You're
Voice got
muted.
cut.
Cut. Pritham, can you unmute yourself?
Yeah, sorry. Do we need to raise a MuleSoft ticket for transit gateway pairing?
You mean for connecting the AnyPoint VPC with transit gateway?
No, no. Between the two transit gateways for
Okay,
east.
this two transit gateway.
Yeah,
Okay, so if you see this, this transit gateway as well as this transit gateway, both are residing in your own AWS infra.
yeah.
Okay, so this is your AWS infra. You don't need to involve MuleSoft for it. What you need to do is your network administrator, they themselves can do this pairing.
Okay.
Okay.
Yeah.
In fact, for anything related to transit gateway, whether it is connecting these two transit gateways or for connecting one transit gateway with MuleSoft VPC, even for that purpose, we don't need to raise any MuleSoft support case or support ticket. And that's the reason why this offering is completely self-serve.
Okay.
That's the biggest benefit it has over VPC peering and AWS Direct Connect. So only transit gateway and VPN, that is the AnyPoint VPN, are self-serve connectivities. The other two, that is VPC peering and Direct Connect, for that we'll have to involve MuleSoft and raise a support case.
All right.
Yes, we have a question. Yeah, Pritam.
Yeah, go on.
How would so the question from Pawan? How would the routing table look like in this inner region transit gateway case? Would it contain entries from other region as well?
Uh, so we are seeing the routing tables in this particular scenario, right?
I think the overall scenarios, Pawan, need routing table. How exactly it look like for inter-region transit gateway case?
Correct. So inter-region is this scenario, right? So
Okay.
essentially what we'll have is basically this will be a different CIDR block, this will be a different CIDR block, right? All those things. So all those details will be there in this routing table. And this routing table's details will be there in this routing table. Unfortunately, I don't have more details on it because I have not tried it. But pairing is kind of straightforward. Maybe in our next session, we can do this in the demo itself. So today's demo will focus on one region, but probably, Sheikh, if it is possible, then we'll have another demo in which we'll try to do the inter-region transit gateway peering.
Okay. Question from Subham. Do we configure the other transit gateway in routing table? I think it is same only, right?
Yeah. So all this inter-region related routing, we will not cover in today's session because as it is having the demo for this part is going to take time. So let's see how that goes. And then probably in the next follow-up session, we can have this peering part done for two transit gateways and see how all these VPCs can talk to each other then. Is that
Yes.
okay?
Yes, it is okay. Yeah. And the last one from Santosh, actually, but VPC peering, creating a VPC peering, we need a MuleSoft support. I think yes.
Correct.
From yeah. And for inter, basically inside the AWS, if any configuration required, then we need a network administrator from AWS. Means enter basically inside the
Kind
VPC.
of. Yeah. It's better if we have, for example, doing all these things, it's better if we have a network administrator from the AWS side because they are more knowledgeable, right? Especially when handling production related setup and configurations. So let's say from our side, we have limited information, but it's better to involve a network administrator. We can tell them what has to be done. So we can tell them that we need a transit gateway and it has to connect to this VPCs and it has to connect to this VPC and all. Okay. This connection part we can do ourselves, but it's always advisable to have a AWS side network administrator and run all the things through him to that person, just to be sure that we are not keeping any holes, especially when it comes to security and all, right?
So we can go ahead for demo.
Okay. Okay, so what I was planning to do was that we'll split the demo into two parts, okay? The first part will be, we'll try to connect two AWS VPCs, okay, to a transit gateway in AWS itself. Okay, so in this part one of the demo, there'll be no MuleSoft involved at all. It will be just two different VPCs in AWS connecting to each other via a transit gateway. And the way we'll test it is basically we'll have an EC2 instance in both of these VPCs. And what we'll try to do is we'll try to ping from one EC2 instance to the other EC2 instance on its private IP address. So as you know, we have private and public IP addresses, right? So if we try to ping private IP addresses and if there is no connectivity between the two VPC instances, then obviously we'll not get a ping reply. Okay, so that ping will fail. Only if the connectivity is fine, so that is the connectivity is going via direct connect, via transit gateway, then the ping command will work fine. Okay, so that is what we'll try to do in demo part 1. Okay, connect the two VPCs via transit gateway and then test the connectivity. So this is how it will look like. Can I zoom this a bit? Can everyone read this, the numbers and all? If you can quickly confirm me, otherwise I'll open a different image just to zoom all these things.
If it is possible, if it is
Okay.
means possible quickly, then we can go
Okay,
ahead.
I must have it open. Yeah, this one.
Okay.
Is it
Yes.
clear now? I
It is
can
better.
zoom it as much as I want. Okay. Okay, so it's very critical to understand what we're trying to do now in this demo. Okay, so let's start with the basics first. We have a AWS region, this blue box, which is US East 2. Okay, I mean, this is just for the demo purpose. Okay, there's no hard and fast rule that we have to just select this region itself. For the demo purpose, we are having it as US East 2. Okay, we have two VPCs, VPC 1 and VPC 2 over here. Okay, VPC 1 is on the CIDR block 10.0.0./16 and VPC 2 is on 10.1.0.0/16. So the only difference is the second digit 0 and here 1. Okay. Now what we have done is for VPC 1, we have enabled public access. And for that public access in AWS, we need to have something called as an internet gateway. So this is the internet gateway that you see only for VPC 1 that connects basically to the outside world. Okay. Now inside this VPC, we have a public subnet, which is on 10.0.0/24. So if you see, this is a subset of this. Okay. And inside VPC 2, we have a private subnet, which is on 10.1.0.0/24. Again, if you see, this is a subset of this VPC CIDR block. Okay. The next thing is in both these subnets, we are going to start an EC2 instance. This EC2 instance over here is, let's say we call it EC2 1. Okay. And this red boundary over here is the security group that secures this EC2 instance. Similarly, there's an EC2-2 EC2 instance in this private subnet, and there's a security group, the red boundary over here. Now, the thing to note over here is that this VPC, that is VPC2, is completely private. So it cannot be accessed from anywhere. Whereas VPC1, we have just deliberately made it public so that we can just SSH or ping, we can SSH it from PuTTY or from other tools, basically. Okay, so that's the reason we have kept it public. Now, I think previously we discussed about the route tables, right? The VPC route table. So if you see VPC1, okay, it has this route table. I mean, this is a sample route table, okay? What it has is a destination and target. Note the entries over here. Let me just zoom that a bit. Is it clear? Okay,
Yes.
so what we're saying is that if the destination IP address is anything 10.0.0/16, okay, then the traffic has to be kept local. So when we say local, it means that any request that we get, okay, from the VPC to any of this IP address block, we have to send it inside the VPC itself, because the VPC CIDR block is 10.0.0/16. Okay, and the other route that we have defined in the route table is 0.0.0/0. What this means is any other IP address which is not satisfying this, okay, then that has to go to the internet gateway. So essentially, if we get an IP address which is not in this range, it will go via the internet gateway to the public internet. Okay. So now if we compare it with the VPC2's route table, okay, we just have one entry over there, 10.1.0.0/16, which is this, and the target is local. So what that means is if the destination IP address is any one of this block, and if let's say if I just copy this 1 second, maybe some people are not aware of the IP blocks. So okay, let's consider this 16. Okay, so this is, let's say, one of the VPC block. What we're saying is that if the IP address is between this range 10.0.0.0 to 10.0.255.255, okay, and for this one it is 10.1.0.0.16. So if I just put those things over here again, it is a good handy utility. Okay, you can keep it handy. So what we're saying is that starting with this IP address to this IP address, a total of 65,536 IP address. Any one of this IP address, if it is there in this VPC, the traffic will be kept inside the VPC. That is by this route table entry. Now, if there is an IP address which is not in this range, so if it is not from 10.100 to 10.1.255.255, then what will happen in VPC2? There's no second entry over here, so it will not go to the internet, and that address or that request will get dropped off automatically. Okay, so this is the VPC route tables that are there, and the difference between both these route tables. The difference is because this one has public internet connectivity, this one does not have. Okay.
But application can communicate internally via IP address.
Yeah. So let's say there's this EC2 instance, it can talk to any other EC2 instance on the private IP address. So that is fine. Because if you see this, the other EC2 instance, if in case we have it over here, it will have an IP address from this VPC CIDR block. In fact, it will be from the subnet CIDR block itself. So the traffic will be routed inside its internally itself. It doesn't need to go outside because the IP address is within the range.
Okay.
Okay. One last concept that we need to just quickly brush is the security group. Okay. So the security group basically controls the access to the EC2 instance over here. Okay. And what we have set the rules in that security group is that allow all traffic on the TCP protocol as well as ICMP protocol. And if you see, we have done the same thing for the other EC2 group. So why do we need to have this? It's basically because we are going to have the ping command. Okay, so the ping command, we need to have the ICMP protocol enabled. So that's the reason we have the ICMP. And the TCP is basically because we're going to do SSH and all those things, right? So we have kept the TCP open. So this is where we can control in the security groups settings, the source, the protocol, and the port. So these are the inbound rules. In fact, they're called as the inbound rules for the security group. Okay, I hope all this part is clear. The only part pending then will be is that we have this VPC1, VPC2. We'll create a transit gateway, and then we'll connect it to the transit gateway. We'll connect this VPC to the transit gateway. And then the most important thing, that is the testing part. The way we will test it is we will do a PuTTY or a SSH login to this instance, EC2 instance, on this IP address. So this is the private IP address of EC2-1, this instance. And then once we log into this EC2 instance, what we'll do is we'll ping the private IP address of EC2, which is 10.1.0.25. Okay, so this is completely private. There's no other connection for this VPC2. The only connection that is possible is via transit gateway. So if this works, it will ensure that our transit gateway is set up and working properly. Okay, so what we'll do is we'll now quickly log into AWS console. Okay, I have kept a few things ready because it's going to be a lengthy kind of a demo. So certain basic things such as the setup, few things I've kept it ready, but just to make sure everyone understands the setup, I'll just go through that settings, and then the rest of the settings which are critical for this demo or more pertinent to this demo, that is a transit gateway setup and all, that we'll do ourselves. Any questions so far, or can I proceed? Understanding this use case is very important. Okay. In fact, what I can do is, so this is, as I mentioned, this is use case 1. We go back. Okay. So this is all about demo 1 or the use case 1. What will we do in part 2? So the part 2 is basically with MuleSoft. So we'll have the previous setup as it is, okay, in which we connected to 2 VPCs. What we'll do in part 2 of the demo is that we'll connect the MuleSoft Cloud of VPC with the transit gateway. Okay. And then we'll test the connectivity from Cloud of VPC to both the AWS VPCs by pinging on the private IP addresses. So this will look something like this. Again, I'll open another diagram so that it's easier. Yeah. So if you see, this part is completely same. There's no change over here. The only difference is now this is to this transit gateway. I have this US East 2. Again, if you see this matches US East 2, US East 2. I have created a MuleSoft VPC, a normal VPC in our AnyPoint platform cloud hub. Okay. I have created a VPC. The critical part is on the CIDR block 10.2.0.0.16. So VPC 1 is on 10.0.0/16. VPC 2 is on 10.1.0.0.16. And VPC, or the MuleSoft VPC, or you can call it as VPC 3, it's on 10.2.0.0.16. So just for clarity, I've named it in sequence 10.0, 10.1, and 10.2. In all are /16. Okay. Now, as you know, we can deploy any Mule application inside this VPC. What I've done is I have deployed an application provided by MuleSoft itself called as a NetTools app. I think some of you might be knowing this app is actually used for testing the connectivity. So to see if the connectivity from the MuleSoft VPC to the on-premise network is working fine or not. So all those things we can test via the NetTools app. And this is the private IP address of the NetTools app. So the test that we'll do once all these things are set up is that we will go to the NetTools app. From the NetTools app, we'll try to ping this IP address 10.0.0.237 and see if it is successful. And then what we'll do is we'll try to ping 10.1.0.25 and see if that is successful. And then as a last step, just to check if the other way it's working fine, what we'll do is we'll log in again via SSH PuTTY to this particular EC2 instance. And from here, we'll do a ping for the NetTools IP address, the private IP address, 10.2.229.72. Okay, so once we do all these three tests, basically, we'll confirm that the connectivity is established in both the directions then. So is the use case for the demo clear with everyone, or are there any questions? Because I think it will make sense to address the questions now before we start the actual demo.
Yeah, Vaibhav, we have one question from Faizan. In this app, that is NetTools app, we can give IP address only or DNS name as well?
We can give both. We can give the DNS names too.
I think no more questions. We can go ahead.
Okay. So as I mentioned, in the interest of time, we have certain pre-configurations done. Let's go and quickly check that, what all things we have ready. So I'll just go to my AWS console. Okay, so now in my AWS console, I hope everyone is able to see my screen. The first thing to note is the region. So the region is displayed over here. I'm in Ohio. So Ohio is basically US East 2. Okay, so if I go back to the diagram, US East 2. That is this thing, Ohio. Okay. Now the first step is basically the two VPCs, the creation of the two VPCs in this region, that is Ohio. Okay, so let's see. Let's go to the VPC section. We can just create VPC over here. Okay, so you can see some VPCs over here. Ignore this default VPC. This is one created by AWS by default when we create an AWS account. The ones that we want are VPC-1 and VPC-2. Okay, the state is available. The other critical thing to check is, let's say for VPC-1, it is on the CIDR block 10.0.0.16. This matches with our diagram over here, 10.0.0.16. Okay, and VPC2 is on 10.1.0.0.16. Okay, 10.1.0.0.16. Okay. Now the next step is basically we have to check the internet gateway connectivity for VPC1. So that is this part we have to check now. Okay, so for VPC1, we need to check if this connectivity is there or not. So we'll just quickly go to internet gateways. Okay, so you can see, okay, so we can see this IGW1 and it is pointing to the VPC1. Okay, so we have this IGW1 as the internet gateway connected to this VPC. So this is essentially this setup, that for the VPC, we have an associated internet gateway. Okay. Once this is done, the one thing that you need to check is go to your VPCs again. And guys, let me know if I'm going too fast. Okay. If I'm going too fast, I'll just slow down a bit. Okay. Okay. So the next thing to check is we mentioned a bit about the root tables, right? The VPC root tables. So let's have a quick look at the VPC root tables. So I've selected VPC1 over here. Okay. Let me just click this. Okay. Again, you can confirm this idle block for VPC1. Okay. And then there's something called as a root table over here. Okay. So let's click this. You can see these root tables. Let's see the roots over there now. We go over here. Okay. So this is a very important part of the demo. Currently, we just have two routes. Destination 10.0.0.16, which is the current VPC's CIDR block. Then what we're saying is that traffic should remain local to the VPC. When it is local over here, it means local to the VPC. Okay. Please don't be confused. This is local to the VPC. Okay. The status is active. Propagated is no, that is fine. Any other IP address, it has to go to this. This is the internet gateway that we just have connected. Okay. So this is the first VPC's root table. If I go to the other VPC, so this is the second VPC's root table. If I open this, okay, and if I go to roots, if you see and note, there's a slight difference over here. Now the destination is 10.1.0.0/16, which is the CIDR block of VPC2. Let me just quickly open 10.1.0.0.16. Okay. The target is local. So any traffic for this destination remains local in the VPC. It is active. But now we don't have the connectivity or the route to the internet gateway. Why? Because we have not set it up over here. Okay. So we have completed two parts. We have created the VPC. Okay. We have created the internet gateway connectivity for VPC1. So all those things are created. The root tables are there. So this part, the one in green, are there for both the VPCs. Okay. So the next step now is to look into the subnet. So this public subnet and this private subnet. Okay. So let's go back again over here. There's a section called as subnets on the left-hand side. Click that. Ignore the other subnets. I have marked the ones that we want as VPC1 subnet 1 and VPC2 subnet 1. So VPC1 subnet 1 is the subnet in VPC1. VPC2 subnet 1 is the subnet in VPC2. Okay, let's open VPC1 subnet 1. Okay, so if you see over here, let me just scroll down a bit. This is on the CIDR block range. If you see 10.0.0/24, let's compare it with the diagram 10.0.0/24. Okay. The next thing to check over here is the root table that the subnet is using. And if we see this, this is referring to the VPC1's root table itself, the one that we just saw. All right. I think that's all in the subnet that we have to see, nothing more. Let's go back. Let's go for VPC subnet 2 now. If we select this. Okay. Again, confirm the CIDR block 10.1.0.0/24. Let's confirm it with the diagram 10.1.0.0/24 for the subnet. Okay. And the root table, it is using VPC2's root table. Even if you want to confirm, you can just scroll down. I think there's a table. Yeah, if you see, there's just one root. This is VPC2's. All right. So these are both the subnets that are there. Okay. So this is basically all the configuration that we had to do till VPC public subnets. Now the pending configuration to check is the security groups and the EC2 instances. Okay. So to check that, let's quickly go again. For security groups, we need to open EC2. Okay, in EC2, if you scroll to the left, there's something called a security groups. So let's go over there. Ignore the other ones. There's just two ones that I have named it. EC2 1 security group SG and EC2 2 security group SG. Okay. Now, the only thing to note down is when we create these security groups, make sure that you create it in the appropriate VPC. So, for example, when you create a security group, it asks you for a name over here, and then it asks you for a VPC over here. So, make sure that you create the first security group in VPC 1 and then the second security group in VPC 2. That's the only thing that you have to keep in mind. Okay. So, that's what I've done over here. Let me just quickly open EC2 1 security group. Okay, so I think if you see this, this is going to point to VPC1. Okay, and then the most important thing is for this security group, the inbound rules that we discussed. Okay, what we are saying is that we are allowing traffic on port 22. This is for doing put your SSH basically from any source as well as ICMP. So the ICMP protocol is for the ping command. So we are allowing that traffic only inside this security group. And the same thing we have done for the other security group. So if I just click the C2 security group now, this will point to VPC2. And if I scroll down, we have the same entries over here. Okay, so just be allowing ICMP for ping and TCP on 22 for the SSH part. Okay. Now the only thing pending now is creating the EC2 instances. Okay, so rest all is done. Only the EC2 instances are left to be created. So let's quickly check that. If you just keep going up, I think instances. Yep, you can see there are two instances created. Again, it's super simple to create these instances. Just click launch instance. Okay, it will give you a lot of. In fact, most of you must have worked on this. So just give some name over here. You can select whichever OS and all those things that you want over here. And then you can select type of instance over here. If you want some keypad to be there to when you use logging, then you can collect over here. The critical thing is this part, network settings. So we don't want the default network and all or the default VPC to be used. So this you have to just change it. Make sure for your first EC2 instance, you select VPC1. Okay. Subnet, we just have one subnet, so automatically it will be populated. Select that one itself. Okay. This is a critical part, auto assign public IP. So for VPC1, if you see this diagram, we need to have public access to this. So for having public access, we need to assign a public IP. So the only difference will be here, it will be enabled. And for the other EC2 instance, in VPC2, it will be disabled. Okay. The other thing is that instead of creating a security group, we'll have to select an existing security group because we have already created one. So let's select it over here. This is our security group. Just select it over there. And I think that's pretty much it. Yeah. So only this settings and then click launch instance. What you'll get is a new instance created, which will look something like this. If you click it again, you'll be able to see all the details. The things to verify over here is it has a public IP address assigned. Okay. So this is the IP address that we'll be using when we do an SSH to the instance. Okay. And the most important thing is it also has a private IP address assigned. And now if you see this private IP address 10.0.0.237 and match it with our, yeah, so if you see this is matching 10.0.0.237, which is the private IP address of the EC2 1 instance. Okay, it is a part of VPC1, just to be sure that it is part of which VPC, and it is a part of VPC1 subnet 1. So all this information you can get in this EC2 page itself. Now make a note of these things, and then when we go to the other instance, you'll see the difference. So this instance, EC2 is a private instance. So it does not have a public IP address. It just has a private IP address, 10.1.0.25. Let's ensure that we have the same thing inside our diagram. Yeah, 10.1.0.25. Okay. This is super important because we need to test whether we are able to connect using the private IP address. Then only we can confirm that the connectivity is working fine. Okay. The other thing is just to verify VPC, it is connected to VPC2. Subnet, it is using VPC2 subnet 1, and that's pretty much it. Okay. Is everything clear so far? Because what we've done right now is created this entire thing. Not entire thing, sorry, my bad. We have created a VPC and everything inside. This VPC and everything inside. The only thing pending now is getting the transit gateway. Okay, so this is the part that we'll actually do right now. But before that, I just wanted to confirm if everyone is clear on the setup that we have so far. Any questions that we have so far?
Yes, no question.
Okay, so we can proceed.
Yes.
Perfect. So we have these two VPC instances which are perfectly ready, but they are not connected to each other. How do we know they are not connected? Because we do not have any connection, but still, let's verify if they're connected or not. Okay. So what we'll do is we'll log into this EC2 instance and try to ping this private IP address and see what happens, just to have a quick test. So for that, let's go back to the instances. This is EC2 instance. Let me select this instance, the first instance, which is a public instance. I'll click connect. Okay, I'll use EC2 Direct Connect itself. I'm not going to use putty and all right now. Okay, so we are basically now good to run the commands. So what should we run? What we are trying to do is we have logged in into this instance. Now we have to ping this 10. Let me just zoom it for you. We have to ping 10.10.25 and see what happens. Okay, so let's do a ping. If you see, there's no response. It's waiting for a response, but there's no response. Otherwise, normally within a couple of seconds, we do get back some response. So since we're not getting a response, what does that mean is that there's no connectivity established. So what we'll do is we'll just abort this. Okay. And then what we'll do is we'll continue with the rest of our configuration. So now we have verified that the connectivity is not there. So we need some help. And who's going to help us is the transit gateway. So let's start with configuring the transit gateway. Okay. Let me go back to my page again. Sorry, not this. Yeah, over here. So what I'll do is I'll select VPC again. Let's open it in a new window so that it's easier. Okay. Now what I'm going to do is create a new transit gateway. The first thing to ensure that the region is correct. Okay. After that, scroll down. There's a transit gateway section over here. Go to transit gateway. Okay. As of now, there are no transit gateways. What we'll do is we'll create a new transit gateway by clicking this button. Okay. Let's name it TTW-1. So transit gateway 1. So any description that you want. There is something called as an ASN or autonomous system number. If you click over here, it mentions what it is there. This is more needed when we are doing a VPN connectivity and all those things, because especially when there is a BGP protocol getting used. But since we're using just VPC attachments, which are going to use static routes, then we don't need to mention over here. It can just use any number over here, the default number, I mean. But if we want, we can put any number from this range. So these are the range that are specified. Anything from this range we can put over here. The only thing we need to ensure is if in case we connect to another network which is having BGP and we are going to have dynamic routing in place, then we need to ensure that the ASN over here is different to the ASN for that particular network. Okay. For now, we can ignore it, keep it blank, no need to do anything. Okay. No need to do anything over here. These are just the tags, name and TG1. That's it. Create transit gateway. Okay, so if you see now, this is in pending state right now. Probably it takes about a minute for the transit gateway to be up. It shouldn't take more than that. So to be honest, we don't have any other option but wait for a minute, because this is the first step, and until and unless this gets completed, we cannot move further. Okay. I'll just quickly refresh it periodically to see if it is working fine. So during this demo, there'll be a couple of places where we'll have to wait for the things to be up. Okay. So in that time, I think we can utilize, if there's any questions, then we can probably make use of that time. So any questions so far, you can let me know till this is okay. Fine. It's now available. So before proceeding, that's the first check that we have to do, that the transit gateway that we created in AWS is available. Okay, so that's the first step that is done. Now the thing is, what do we need to do? Let us go back to the diagram. So if you remember, for connecting a VPC to the, we have this box now. Okay, we just have a box now, but we don't have these links. So to have these links, what we need to do is we need to create an attachment for VPC1 and another attachment for VPC2 so that it connects with the transit gateway. So let's get it done. So on the left-hand side, just below transit gateway, there is something called as transit gateway attachments. Click that part. Okay. So right now there are no transit gateway attachments. What we need to do is click this big button over here, the create transit gateway attachments. Okay, so let's first create attachment for VPC1. So what we'll call it as TGW1 VPC1. Like what we're saying is transit gateway 1, which is a transit gateway, and VPC1. So this attachment will attach VPC1 with the transit gateway. The next step is select the transit gateway ID. So if you select the drop down, since we just have one transit gateway that we just created, we'll select that. Now this is the thing that we have been talking this entire session, the attachment type. If you click this drop down, you can see all the permissible attachment types: VPC, VPN, peering connection, connect. Okay, VPC is for VPCs, VPN is for VPNs. It's, I think, quite clear. Peering connection, this is basically for the transit gateway inter-region peering connections. And connect, this is the AWS Direct Connect. Okay. So since we are going to attach a VPC to the transit gateway, we'll keep it as VPC itself. Let's scroll down. Yeah, so this is the most important thing now. What does this attachment do? It is going to attach VPC1 with transit gateway. So we have to select VPC1 from here. Okay, selected the VPC1 with subnet. So since we just have one subnet, we can just keep it as it is. No other changes needed. Okay, this gets auto-populated, the name. Once this is done, click create transit gateway attachment. Okay, so this, if you see this is also current status pending. What we have done in this is that we are creating a new attachment called as TGW1 VPC1, which is going to connect VPC1 with the transit gateway. So what we're trying to do is this part. So we are trying to connect this, the arrow over here. So as I mentioned, this is again probably going to take a minute or so. So till this gets up and available, what we'll do is we'll create the attachment for the other VPC. So the steps are the same. I think what was the syntax that we followed? TTW1 and then VPC2, right?
Yes.
Yeah, so this will be the name for the other transit gateway attachment. Select the transit gateway again, TTW1. Again, the attachment type is again, since we are connecting another VPC, this will remain as VPC itself. Scroll down, the most important thing, select the VPC. But now we are not going to select VPC1, we are going to select VPC2. Okay, that is selected. The subnet is there. We don't need to change it because it's just one subnet. That's it. Create transit gateway attachment. Okay, so now we have both these transit gateway attachments. Okay, let's see where they've reached. Okay, so the first one is ready. It's available. The second one is still pending because we've just triggered it. Probably it will take a few more seconds for it to be available. Any questions so far?
Yes, no question.
Any confusion or anything like that? Because it's going to get slightly complex. So if in case anyone is getting confused, please do let me know. I can just revisit those concepts or that part of the demo. Let's see, it's still pending. Unfortunately, we cannot proceed until both are up. So let's wait. Oh, perfect. So we have two transit gateway attachments, which you can see on your screen: TJW1, TJW1 VPC1, VPC2. Okay, both are available. There's a quick check that we need to do if indeed they are properly attached, and that is by going to the transit gateway route tables. Okay, so click this link over here. So this is the route table of our transit gateway. So even you can go from, I think if you go to transit gateways, and if you click this, there's I think this one. Yeah. So this is the same route table. Okay, you can go from transit gateway or you can come from here also. It is the same route table. If you click this, you can able to see all the details over here. So the thing that we need to do is go to the routes tab over here. Okay, scroll down a bit and see what we've got. We've got two routes automatically entered inside this transit gateway route table. The first route is for CIDR block 10.0.0.16. Okay, and it is for this VPC. Now, if you want, I'll open this VPC in a different window. If you see, this is VPC1. Okay. So what has happened is that in the transit gateway route table, there is one entry now for CIDR block this, and it is pointing to VPC1. And that is actually what we want, right? Because if you see this diagram again, our VPC1 is on 10.0.0.16. So 10.0.0.16, please forward it to this VPC. Similarly, 10.1.0.0.16, which is the other VPC. So please forward it to this VPC. The only thing you need to check is that the root state is active. So both the roots are now active. Okay. So that was a quick check to just check if the transit gateway route table has been updated or refreshed after the attachments were added to the transit gateway. Okay. Now, one question over here. Let's go back to the diagram. Okay. So we have attached this VPC. We have attached this VPC. Now the question is, if I do a ping now from this EC2 instance, the same test that we did earlier, if I do a ping now from this EC2 instance to this EC2 instance, will it work? Let's quickly find out. So we'll go to, where is our EC2 instance? Yeah, it's here. In fact, it's here. So I think it's got crashed. Let me just open it again. Perfect. So let's run the same command which we ran, which is ping 10.10.25. Okay. Ping 10.10.25. What we get now. So I think, as you might probably make out by now, we're not getting any response for the ping command. So even though we have attached the VPCs to the transit gateway, still the connectivity is not completely established. So I'll abort this, okay, and let's see the missing link now. So if I visit a diagram again, we have attached it to the VPC, right? But still, when we're trying to send traffic from this instance to this instance, it is not reaching it. And the reason why it is not reaching it is because we're sending the traffic from this, okay? But it can either go inside, if you remember this route tables that we had for this VPC, right? So this was exactly the route table that we had for the VPC. So when we are sending traffic for 10.10.25, is it in this CIDR block range? No. Is it in this CIDR block range? Yes. So what it is doing is it's sending it to the internet. So it's sending to the internet, And then it is getting lost in the internet because this is a private IP address. There will be no device or nothing at all on the internet for this private IP address. So that's the reason you're not getting a response. And then how do you fix this issue? The solution to fix this issue is updating this root table for the VPC by adding an entry over here such that any request to this VPC CIDR block, that is 10.1.0.0.16, so that will be the destination over here. And then the target over here, that is the important thing. Where do we want that traffic to go? The answer is the traffic should go to the transit gateway. Because only after it reaches the transit gateway will know that it has to forward it to this VPC. Okay, so that is a step that we'll have to do now. Update the VPC's root table by adding one entry over here. And then the same step for VPC2's root table, we'll have to add a new entry over here. But here the difference will be the destination will be VPC1 CIDR block and the target will be transit gateway. Okay, so let's do that. Let's go back to our VPC. Okay, and we have these root tables, right, for both those VPCs. So this is our VPC1 root table. Let's click that. Okay, so these are the two routes we have. As I just mentioned, it has a route only for local and to the internet gateway. What we need to do is add a route to the other VPC. So click edit routes, add route. So what's the CIDR block for the other VPC? You can get it from the diagram or you can get it from the EC2 instance route. It is 10.1.0.0.16. So put it over here. Target. As I mentioned, the target over here is going to be a transit gateway. And since we just have one transit gateway, this is the transit gateway and TTW1 VPC1 is the attachment which we are going to use. Okay, that's it. Click Save Changes. Okay, so one route table is changed. Let's go back to the other route table. Okay, let's go to the route section. It has just one entry for local because this is the private VPC. Let's go over here, add a route. So now what we're doing is we're adding a route for VPC2's route table such that it can propagate traffic for VPC1. What is VPC1's IP address or the CIDR block? 10.0.0/16. So let's put that over here. And then the target is, again, as you might have guessed by now, transit gateway. Save changes. Okay. So I think probably we have done everything. All the settings are done. So I think it would be a good time to now retest again and see if the connectivity is working. So we have this open. Perfect. Okay. What we're gonna do is ping the same command again. Let's go and check the IP address just to be sure. 10.10.10.25. Let's see what happens now. So if you see, we're getting response now. We're getting the response and response from the other 10.10.25 over here. Okay, let's stop this. So this concludes demo 1. Okay, and what have we achieved in demo 1 is basically this entire setup. So we had two VPCs, public subnet, EC2 instance, another VPC, private subnet, EC2 instance. We connected both VPCs to a transit gateway, and then we pinged from one EC2 instance in one VPC, the other EC2 instance on its private IP address. So before the setup was in place, the ping was not working. Once we got all the setup properly done, the ping was successful. That actually says that the connectivity is properly established. And now anything on this particular VPC can access anything in this particular VPC. Any questions so far before we move to part 2?
Hello guys, any question? Please ping me in the group or chat. So demo, wonderful demo. First demo is very wonderful, awesome.
Great. Sheikh, if it's possible, can we take a 5 minutes break and then we'll join again for the second demo? Is that okay?
I think how much time it is taking the second demo? Because I think
It
we
will
can take
probably
from
take
one.
around.
Uh-huh.
It will probably take around half an hour at least, I would say.
Basically, what happened here is when we joined, so it is not kind of that we logged out and log in. So if we complete in the flowing, then it is okay.
Okay. Do you want me to continue then?
Yes, yes.
Okay, no problem. So if no other questions, then we can quickly continue with demo 2. So demo 2, as I mentioned, is, sorry, not this one. This is this one. So we are going to use all the infra that we have set up so far on the right hand side. And now comes the interesting part in which we are going to connect the MuleSoft side. Okay, so let's start. So the first step is, let's go back and log into our AnyPoint platform. Sorry. Just open it in a new window. Please, I'll just quickly log into the platform. Okay, so the first thing that we need to check when we are connecting our Cloud Hub to a transit gateway is that we need to ensure if we have the right entitlements to connect to a transit gateway. Okay, so that's the most important thing. Okay, so it will all depend upon multiple things such as your license and all. So please do ensure that you can see this transit gateway option over here in Runtime Manager. As well as to make a transit gateway connection, the other thing that we need to check is in access management, if you go, we need to have the network connections entitlement present. So something like this, we have this network connections, right? So this gets used for VPN connections as well as transit gateways. So make sure you have available network connections. Okay, let's go back to the runtime manager. Okay, so there's actually one thing that I've created beforehand, which is a VPC at the AnyPoint platform side. This is the name of the VPC. There are a few things that we have to note over here. The region. The region matches with what we have at the AWS side of the transit gateway, and the CIDR block 10.2.0.0/16. So if you see this, let me close this one now, just this one. This is exactly what we have in the diagram, 10.2.0.0/16. Okay, so we have the VPC created. VPC is pretty straightforward. I can open it for you. There's nothing over here. I've just included the sandbox environment. I've not done nothing for the business group, no changes in the firewall rules, nothing in the internal DNS. Okay, the only thing I've done is I have assigned a particular CIDR block. There's nothing else different in this VPC. It's just like a normal VPC. Okay. The reason I created this VPC beforehand is because I have deployed one application. I'll go to the application, which is the NetTools application. So normally if I go to deploy on the demo time, it will take quite a bit of minutes. So to avoid that, in the interest of time, I've deployed this one single application, which is deployed in that VPC. Okay. So let's start with connecting this VPC, which is Meetup-VPC, with our transit gateway. So for that, click the transit gateway tab. Okay. I think this is an existing one, so ignore that one. Click add transit gateway. Okay. It shows a pop-up over here that we need access to the AWS account, which we already have. Then basically it's talking about some resource share, which we'll be doing. And then it is talking about attaching VPCs. Okay. So let's click ready. Okay. So what we have to do is add a name for the transit gateway. Now, a couple of things to note over here is that this is just a name that will be displayed on the AnyPoint platform side. This name does not need to be similar to the name that we have over here in AWS for the transit gateway. Okay, so if you scroll down over here, we had TGW1 for the transit gateway over here, right? That doesn't mean we need to have the same name over here. We can just rename it anything. So let's say we can have TGW1-MS. Okay. The important thing over here is that the region we select. So it has to be the same region where the actual transit gateway is. So we'll select US East Ohio because US East Ohio is US East -2. Okay, click next. A few steps that it mentions, that create a resource share and then do these steps. So what we'll do is we'll just quickly go and do these steps. Okay. So what it is asking is to first go to AWS and create a resource share, and then the next step will proceed. So accordingly, we'll go to AWS. What you need to do is search for something called as RAM, which is a resource access manager. Open it in a new tab. If people are not aware of what a resource access manager is basically a tool provided by AWS by which we can share resources from one AWS account to another AWS account. Okay, so in this case, what we're going to do is we are going to share the direct connect, the transit gateway resource from this AWS account, which I've logged in over here, to my MuleSoft account. So as you know, MuleSoft is also an AWS thing, right? So it also has an AWS account. So by doing this step, what we're going to ensure is that the direct connect, I keep on saying direct connect, the transit gateway that we have created gets shared with MuleSoft. Okay, so click create a resource share. Let's put something like MuleSoft resource. Just any name that you want to give, you can give here. Now, this is the important thing. What do you want to share by this resource share? So do we want to share subnets? No, what we want to share is transit gateways. So select transit gateways. It will select your transit gateway. Since we just have one transit gateway in this account, it will select it. Let's check mark it. Okay, it is selected. Scroll down. Okay, I don't think we need to add anything over here. Click next. Okay, these are some default permissions that are getting assigned. We don't need to make any changes over here. Click next. Okay, now what it's asking is, whom do you want to share it with? So we are creating a resource share, but which account do you want to share it with? So that is what it is asking over here. So what we're saying is that this principal is going to be, the principals can be anything such as organization, IAM role, or anything. What we're saying is that we are going to share it with an AWS account. We are going to share it with the MuleSoft, our own Cloud Hub account that we have, the MuleSoft AnyPoint platform Cloud Hub account ID. But how do we get this account ID over here? We can get it via this screen. So this pop-up that we had, it shows something like under principals at the MuleSoft AWS account ID. So this is going to be unique for your account. Whichever account you try to create a transit gateway, this will be unique. So what you have to do is just copy this as it is. Okay. Go back over here, paste it over here, then click add. So what you have done is you have selected this AWS account to be added to this resource share. Click next. So this is reviewing whatever we have done so far. We have selected the transit gateway to be shared as a resource. Okay. The permissions, the default permissions on the transit gateway, and then which AWS account that we have to share it to. So this is the AWS account of our Cloud Hub account. Once all that is done, click resource share. Okay, so this is now creating a resource share. Okay, so this is quite instantly created. There are two things that we have to note over here. One is the owner ID and the the resource share ID over here. And the reason we need to note is because if we go over here, so these all steps are done. Click next. That's what it asks for pairing both the connections, right? So it's asking the resource share ID and the owner ID from the resource share that you have just created. So what we have to do is copy the values from there and paste it over here. So let's go back. Let's get the owner ID first. The ID is pinged over here. Then the owner. Sorry, I did it wrong. This is the owner ID. This is the owner. Then the ID. The ID will go over here. Then click add. Okay, so you can see some messages over here. We are connecting to with AWS to add your transit gateway. This may take up a minute. So it's basically wait and watch now for a couple of seconds. Okay, so the first step is completed now. We have this AWS details that are transit gateway ID. You can see the gateway ID, the region, the resource chain ID, and the owner ID. If you want to verify if it's all right, just check this transit gateway ID. It is ending with FE9F. Go to your AWS page, go to your transit gateway. Yeah, so if you see this, it is the same gateway, FE9F. So the IDs are matching over here, FE9F. Okay. So this is one step complete. Yeah, sorry, go on.
So we created one gateway from MuleSoft. It ultimately created in the AWS.
Yeah, so actually what we have done is we have connected the MuleSoft account. Okay, MuleSoft account is basically a AWS account itself, right? So we have connected this AWS account of MuleSoft with the account of our AWS where the two VPCs are there. Okay, so if I go to the diagram, this account is now connected to this account and it is able to access this transit gateway because of the resource share. Still, we have not completed this part where we are going to attach the VPC, this particular VPC, to the direct connect or to the transit gateway. So that is the next step now, where we will actually attach the VPC from the MuleSoft side to the transit gateway. Okay, let's go for that. So that is this section over here. Okay, so first confirm if this is available. Once this is done, you can attach an VPC so that you can access your transit gateway. So click attach VPC. Okay, automatically it will show you all the VPCs which are in the same region, because VPCs in the same region only can be attached to the transit gateway. So I'll select this, the VPC that we created, click next. Okay, there's a message over here. What it says is that we have to go to AWS transit gateway attachment page. Once we go over there, there'll be something they are saying it will be in pending acceptance status. You have to confirm it that it is from this resource owner ID. If it is from this, please go to actions and accept it. So let's see if this has actually happened or not. Okay, so we'll go to AWS now. Let's go to transit gateway attachments. Okay, wow. So what we can see is this was the attachment that we created. Let me just click it. This was the second attachment that we created. But now I can see a third attachment. We did not create this, but it has got automatically created. So this is what CloudHub has done when we clicked attach VPC over there. Okay. How do we verify if this is the actual attachment? It's quite simple. Click this attachment. It will show you the details. It will show you this resource owner ID. Now confirm this number, the ending digit 0463 and 0463. So that is kind of a confirmation that this is indeed what CloudHub has sent across to AWS, and it is the same thing. It is the same attachment that CloudHub is trying to create. So as per the instructions over here, what we have to do is go to actions and accept it, because right now it is pending acceptance, right? We didn't see that status. Okay, so I selected this. Let me scroll to the right. It is pending acceptance. Okay, so the next step is select it, go to actions, accept transit gateway attachments. Are you sure you want to accept it? Yes. Okay, so once this is done, it is still pending, so it will take some time. But meanwhile, from clarity purpose, we'll just rename this to GW1 software. Okay, so that there's no confusion. So now we have these three attachments. One is the one that we create. This is the one that we created, and the TGW1 MuleSoft is what actually CloudHub created. Okay, let's wait for it to be up. It will probably take a minute or so. Meanwhile, what we can also do is we can go back to this page, click done. And what you'll see over here is the VPC is not attached. You might need to accept the attachment in AWS. So we have completed this step. And the attachment state is still not attached. So we need to wait till this gets changed to attached. Okay, till that is done, let's just quickly look at these details over here. The CIDR block 10.2.0.0.16 local 0.0.0 internet gateway. So I think by now this is all clear to everyone, but I'll just repeat once more. This is our MuleSoft's VPC CIDR block. I'll just go over here 10.2.0.0.16. Okay, so what we're saying in MuleSoft side is that in the MuleSoft, if any traffic is for destination CIDR block IP range this, then keep it to the MuleSoft VPC itself. You don't need to send it anywhere outside. But if it is not any IP address, destination IP address from this range, send it across to the internet. Okay. Okay, so let's see where we are with this. Oh, perfect. So all three attachments are all up and running, including the MuleSoft attachment. So if we go over here, the MuleSoft page, we should be able to see it as attached now. Let's quickly check. Yeah, perfect. So if you see this message is important that it is attached to Transit Gateway. Okay. Now there is one final step that is still missing, which will, okay. We have attached this VPC now to this Transit Gateway. If we do a connectivity test now from this VPC to this VPC or to this VPC, will it work?
No, it will not work.
And the reason for that is?
I think we have not made entries into route tables.
That is correct. So there's a couple of entries that we'll have to do in the route tables. One, in this side route table, we have to make entries to connect to this VPC and to this VPC. Then we have to connect and make changes to this route table that we had to ensure that any traffic for this VPC, that is the MuleSoft VPC, has to go to the transit gateway. Similarly, for this VPC, we have to make an entry to ensure that any traffic for the MuleSoft VPC has to go to transit gateway. Okay, so we'll do it step by step. First, we'll change the route table for the MuleSoft side. Okay, so the way to do it is go to a MuleSoft screen. It's quite simple, in fact. This add route option over here. Click add route. What VPC do we want to connect to? We want to connect to 10.0.0/16. Okay, so select it over here. 10.0.0.0/16. Okay, click add route. Okay, so one route is added now. You can see over here 10.0.0/16, and then the next stop for that address or that traffic will be transit gateway. Similarly, add another route. And 1.0.0/16. So this is the cider block of this one, 10.1.0.0/16. Add route. Okay, so we have all the routes now added. Okay, 10.0.0/16. This is a VPC1. Go to transit gateway. 10.1.0.0/16. VPC2. Again, go to transit gateway because transit gateway will know how to forward it to the appropriate VPC. 10.2.0.0/16 is all local traffic, so keep it local. Don't send it outside VPC. Any other IP address which does not satisfy these three rules, send it to the internet. Okay, all clear over here? So we have done all the settings from the MuleSoft side. Now we have to make some entries into the two route tables over here. That's for VPC1 and VPC2. So let's quickly do that. Let's go back to AWS, go back to the route tables over here. Okay, so VPC1 route table, let's quickly click it. Okay, so scroll down. Let's go to routes. We have these three routes. I think everyone is clear with these three routes. We worked on them. Everyone knows what it is. Edit routes. Add a route. So what's the IP address that we need to put? Let's check again. It is this cider block, 10.2.0.0/16. Okay. And what's the destination? It's going to go to the transit gateway with the attachment. Okay. Save changes. Okay. So this is how the route table now looks for VPC1. 10.0.0/16, all traffic local, keep inside VPC1. 10.1.0.0/16, this is VPC1 traffic, so send it to the transit gateway. Transit gateway will then forward it to VPC1. 10.2.0.0/16, this is the MuleSoft VPC. So even if it is the MuleSoft VPC, don't send directly to MuleSoft, send it to the transit gateway. The transit gateway has all the configuration to forward it to MuleSoft. So the target is transit gateway. And then for everything else is the internet gateway. So this is done. Go to the other route table. VPC2 route table. Okay, scroll down. Just have these two entries over here. Edit routes. Add route. Again, select the same one. 10.2.0.0/16.
So, Bhoapl, can we say this it's a kind of IPv4 thing?
It's not whitelisting. It's like the entire CIDR block you're allowing traffic. It's not just one single IP address. It's the entire CIDR block where
Yeah,
you're allowing traffic to be propagated.
IP whitelisting the range they are whitelisting, right? So they can play into this range only, right? They can entertain this range
Yes.
only.
So the traffic will be propagated only for this range to this particular target. That's what we're saying over here.
So IP whitelists do the same thing. Like they can, like, if we allow
Kind
them,
of,
they
yeah.
can. Yeah, we can allow them. Then we
I
can.
yeah. Whitelist either just blocks it or allows it, right? So here it is going to send the traffic. So there's additional thing of propagating the traffic will be involved over here. Okay, so the other route table now, the second VPC2's route table now is updated. Okay, 10100, which is its own CIDR block, local. 10000, which is VPC1, send it to transit gateway. 10200, 10200, the MuleSoft VPC, send it to the transit gateway. Okay, so we have all these things set up. I think what we can probably do now is just check quickly. What we need to do is we have a private IP address of a EC2 instance over here. We have a private IP address of EC2 instance over here. But this IP address of NetTool apps, there's a way we can get it if in case we do not, if you do not know. And the way is by, as you know, I have deployed this NetTools app, right? Okay, so I can just quickly open that NetTools app. Okay, so this is how the NetTools app looks like. So what we're trying to do right now is get the private IP address of the NetTools app, which is deployed in the MuleSoft VPC. So the way to do it is get this host name entirely. Okay. Put it over here and just prepend it with worker kernel. So what this will do is it will basically try to ping this internal IP address and see what, let's see what we get over here. Okay. So the reason for doing this is I wanted to check the IP address. So this is the private IP address 10.2.229.72. Let's verify it. Yeah, 10.2.229.72. So this is a general thing for anyone. If you have any apps deployed on CloudUp, then you can just append it with MuleSoft internal and the app name and do a ping using the net tools, and you should be able to see the actual private IP address of your worker. Okay. So now we have this noted. It's there also in the diagram. Okay. Now I think we are good to go, right? So what I'll do is we'll clean this console. The first that we'll try to do is from the VPC, that is from the net tools. Let's try pinging this 10.0.0.237. And let's see what we get. 10.0.0. Perfect. So what we have done is we have pinged from the net tools. Okay, the net tools is an app which is deployed in our VPC, Mulesoft VPC, and we have pinged a private IP address, which is this. So that establishes connectivity from here to here. Now let's check the connectivity from here. It is a Mulesoft VPC to VPC2. So VPC2 EC2 is 10.1.0.25. Let's try to ping that. Clean the console. 10.1.0.25. Okay. 10.1.0.25. Perfect. If you see, we got all the response back. So this ping is also successful. Okay. Now one last thing that we have to check is to see from the EC2 instance if we're able to access the MuleSoft instance. So for that, let's go back to our session. This got finished. Let me just open it again. Okay, so now what we do have to do, we have logged into this EC2 instance. I have to do a ping for 10.2.229.72, which is the Mule workers IP address 10.2.229.72. So let's see. 10.2.229. In short, what we have established is connectivity from year to year, year to year, as well as from year to year. So in short, we have established a direct bidirectional connectivity. Okay. In fact, that concludes our demo for today. What are we thought of doing? Let me just start a screen sharing. So we did the demo part 1, demo part 2. So does anyone have any questions based on the demo that we've done so far, or any other question, any other query in general? I know it was a bit lengthy. I tried to, do a few steps beforehand, but still I think it took a bit of time. But I hope everyone has got an understanding of how the transit gateway works now.
What one comment I can say, now we actually know what a transition is gateway. We know the definition and all. We know the concept and all. But the backend story that you provided today is super clear.
Thank you.
That is kind of like, now we can easily say we can connect with the transition gateway, and we can take all this knowledge back, and we can use that, and we can consider if we have transition gateway any challenge, we can go through all this stuff, and we work on that. So that was brilliant. Bravo. Thank you so
That's
much.
great, and that's in fact the intention of this session, that everyone becomes comfortable with transit gateway, what it is, what it has to offer, as well as let's say when we have discussions with our clients, we can also always suggest these options. So in case the client has transit gateway in their technology landscape, they can make use of it, or if not, they can at least try to get it, just to make sure that people understand, especially the client side, that how simple the connections get, especially when we scale up. So let's say if tomorrow there are 10 different resources attached to it, also transit gateway, the network remains simple. So that's the main intention over here.
Yeah. So we have no question. Let me share my screen.
Yeah.
Yeah. Thank you. First of all, thank you, Bhoapl, for very wonderful session and demo part 1, part 2. Actually, I enjoyed this session a lot, and there was a lot of learning from my side, because this is the first time I see the transit gateway, how exactly it is working, and what concept and demo it is. So basically, let me go to next slide. So we have a quiz, and this time we have a three question. So those question I'm going to paste here one by one. One question, and everybody is going to answer. Another question, everybody is going to answer. And third question, answer. So answer would be in the option only A, B, C, D. Like question having question, and answer in A, B, C, D. So you have to just basically give answer in the journal chat. As you can see that you are able to see journal chat. So you have to just only give the answer like A, if the current answer is A, or B, or C, or D. Okay, don't write the answer, because it might take time to written, but you know that answer is. But before you, if someone give directly answer like A, B, C, D, then they might got win. So don't waste your time in typing. Just you can type the option, right? And one by one, I will ask question one by one, and and I basically, the one condition is that whosoever got already winner of quiz in Mulesoft, so I want that we just give a chance to someone who didn't got certificate and training from Mulesoft side. If you are already having, then it is time to give chance to another one which they don't have, or they're trying from very long time but they don't have. Okay, so it is time to paste uh, one first question. Yeah. Yeah, so Deva, we got answer from the chat.
Yeah, I can see some answers on the chat.
So right answer, who's basically given the right answer?
One second. Do you want me to check the chat? Hold on. One
Yes, yes,
second.
yes. But, yeah, I know the answer, but actually I just want from your side.
Okay, okay. Okay, the first person I think who has given this answer is. Let me scroll a bit. I think Amit Kumar Singh.
Amit Kumar Singh, let me.
And that's what I can see on my chat.
Uh, I think it is Preetham. Correct answer is A only, right? And the correct answer is
No, no,
B.
no. B, B. It's B.
Okay. Yeah, Amit Kumar Singh.
Amit
So
Kumar Singh. Yeah.
yeah, Amit, can you ping me your email ID in the general tab, or you can ping
I
me?
will note it down, check. We
Okay.
can.
Do you have email ID?
Yeah, you will be sending. I'll note it down.
Okay, Amit, please send your email ID. I will forward an email for training and certification. Hello, Amit, are you there?
Yeah, we got the ID.
Yes.
Yes, already sent.
Yeah, thank you, Amit. Congratulations.
Thanks.
Yeah, so I'm going to paste second question. Second question. So I think we got answer. The answer is A. And
Faizan Arif is the winner.
Faizan, can you please ping me your email ID? Ping me here. So Preetham going to
Yeah, we
copy.
got it ID.
Yeah, congratulations, Faizan. Let me put third question. It will be true false only, A and B option. So option A and option B. I think we got answer right.
Yeah, it's Sinda Devasi.
Sundar Devasi, can you ping me your email ID? Can you ping us your email ID?
Okay, we got it.
Yes.
Thanks, Sinda.
Yeah. So let me minimize. So after quiz, basically, uh, there will be one link. Basically, there will be one link. Feedback link is coming, and I want everyone to be participate there. So basically, it will help us to basically improve our session, and also you can mention the which topic you want to cover. You can mention your topic, so it will be basically help for upcoming session. So feedback is very important. Okay, so you can do it our Mulesoft Meetup, and if you like the session, then you can post the in LinkedIn and mention our group name and mention the topic name and mention the speaker name. This kind of all efforts taken by speaker Bhoapl. You can mention that it's what wonderful session like that. So we will appreciate it. And the next meetup and date is not finalized yet. The topic is not finalized. So we will uh, update you soon about our next meetup. And if you want to be a speaker, if you have a topic and then you want to be a speaker, then uh, just nominate yourself to me. You can search me on LinkedIn, Sheikh Manadri. If you type, then you will find me, or Preetham. If you can type Preetham Desmukh, then you will also find on LinkedIn. Then we can have basically you can have be a speaker for our Bhopal group. And for now, thank you everyone for joining. Thank you, Vaibhav, for wonderful session. Thank you everyone for basically staying for 2 hours on Sunday. But it give you a lot from Vaibhav side. Basically, it will be basically a very good topic as of now. And
Guys,
yep.
do
It's a
provide your
knowledge
very good feedback.
party.
It's going to help us improvise in future meetups, and we will arrange such kind of meetups in future too. Vaibhav, thank you Thank you for today's session. Although it was lengthy, but it was very informative and very easy to understand. Thanks.
Thank you, everyone.
Uh, can we